Okay, today we will discuss power frequency limitations in microwave bipolar junction transistor. As we know that the main requirement for microwave BJTs is frequency of operation. This device is mainly meant for working in very high frequency, but there are certain limitations in increasing this frequency of operation, and these limitations can be explained in terms of certain parameters. Okay, so the first parameter is there is a maximum possible velocity in a semiconductor. So this is saturation velocity Vs, and Vs is equal to 6 into 10 raised to 6 centimeter per second. Then there is a maximum electric field EM which can be withstood by this material without any breakdown, and it is for the germanium it is 10 raised to 5, and for silicon it is 2 into 10 raised to 5. Also there is a maximum current and which is limited by the base width. Due to these parameters, I mean this maximum drift velocity and maximum electric field, and there is the maximum current limit, there is a limit in frequency of operation. So this can be again explained in terms of certain equations. We have to learn mainly four equations. So the first one is related to voltage frequency limitation. Here the equation is like Vm into Ft is equal to Em Vs by 2 pi. Always remember this term. This RHS is same for all these equation, and this is a constant. Okay. So Vm is the applied maximum applied voltage. Ft is the transit time cutoff frequency, and Em is the maximum electric field, and Vs is the saturation velocity. Okay, so here ft is again 1 by 2 pi tau is a transit time cutoff frequency. Tau is the transit time. Tau is equal to L by V. L is the device length, and V is the velocity of operation. So it may be saturation velocity. Again, this Vm can be expressed as Em into L minimum. So here is one consideration about the length of the material. There is a upper limit in the length of the material. Okay, so since there is a maximum applied voltage and there is a maximum electric field, so L minimum cannot be increased more than a particular value. Okay, so for integrated type my BJT, the L is equal to 250 micrometer, and for matrix and overlay L is equal to 25 micrometer. Again, there is a current frequency limitation. Here Im into Xc into Ft equal to Em Vs by 2 pi. Here Im is the maximum current of the device. Xc equal to 1 by 2 pi Ft into C0 is a reactive impedance, and C0 is the base collector impedance. Okay. So ഇവിടെയും Im ന്റെ value theoretically it is infinite if Xc equal to 0, and it is not possible. Since the reactive impedance cannot be 0, there is always a capacitor between the base and collector region. Again, this power frequency limitation. So this is very important. Pm into Xc, the whole raised to 1 by 2 into Ft equal to EMVS by 2 pi. We cannot increase the power of the device. If we increase the power of the device, we have to decrease the frequency of operation. So that means power capacity of the device must be decreased as increased with the frequency. There is again another consideration, power gain frequency limitation. Here Gm is the power gain, Vth the thermal voltage, and Vm is the maximum applied voltage. So there is a relation between this power gain and the Ft. Power gain and Ft are inversely proportional. So there is a problem. This is asked in for your K2 exam. Certain microwave transistors have the following parameters: reactance X equal to 1 ohm, transit time cutoff frequency Ft is equal to 4 gigahertz, and saturation drift velocity Vs equal to 4 into 10 raised to 5 centimeter per second. And we have to derive the maximum allowable power of the transistor which can be handled. We can use the third equation, power frequency limitation. From this frequency limitation, we know that the equation Pm into Xc the whole raised to 1 by 2 Ft is equal to Em Vs by 2 pi. So we can write the equation for Pm as this. So this is direct substitution. We know all the parameters. Here the given Ft is equal to 4 gigahertz, that is 4 into 10 raised to 9. And we know that maximum electric field is 1.6 into 10 raised to 5, and maximum saturation velocity is 4 into 10 raised to 5. After calculating, after minimizing this equation, you will get the power as 6.48